Ben Pearce, welcome to the podcast.
Thank you. Great to be here.
It's a joy to have you on the show. I'm super excited because you're an astrobiologist, aren't you?
Indeed. Yes.
That's cool. I mean,
I-
already, I think people are thinking you're pretty cool just by that name.
well, that's pretty great. Yeah, a lot of people don't really know what it is because it's kind of like two terms put together, and and oddly enough, it's not really what people think it is when they kind of come up with the definition on their own.
Okay, why
So
don't you explain it for me?
yeah, so astrobiology is really the study of the origins, evolution, search, and distribution of life in the universe. And because we only have example of life on Earth as it stands, it's a lot of it is trying to figure out how life emerged on Earth, and a big portion of it is searching for life on other worlds in our solar system. So, say on Venus or Mars, and also on exoplanets and other solar systems in the galaxy.
Very cool. No, I still think you're in the cool books after that description.
Thank you.
Um, Before we start talking about the science, though, and I have a ton of science questions just out of my own curiosity,
Yeah.
I do know a few things about you. I know that you originally started working. You were not a scientist. You were a software engineer, correct?
Yes, that's right. I
Yeah.
started off with a completely different career, and then found my way to my passion kind of later on in life.
So so what did you do as a software engineer? Did you work for a startup? Did you work for government? What was your job?
Uh, I worked for a few different companies. I worked as an intern at a information identity management software company, and then my probably my longest job as a software engineer was at a actually an oil company, working on oil software to give to geologists so that they could kind of figure out where to drill and stuff like that. And then
Okay,
also,
so
yeah,
no, go ahead, please.
yeah, and then my only other software engineering job was actually in Germany, and that was a testing job. So I was kind of trying to break e-reader software so that it didn't break when the customer had it.
Yeah, it's funny because I come from the software quality assurance world.
Oh, nice.
Yeah, so I can totally 100% relate to you because I've been in IT and software for about 20 years. I just lost my job about a month ago,
Oh,
and
bummer.
it is a bummer, but it's interesting because there's a reinvention process in place now for myself. So when
Hmm.
I heard that you're from the software world and you went into science, I was like, "Oh, this is cool because I can totally relate to this guy." And I think, I'm not the only one. I think a lot of people in the software industry are reevaluating that line of work.
Hmm.
What made you reevaluate your career?
Yeah, I guess it kind of was a long time coming. I didn't go through my undergraduate degree in software. I kind of I never really loved it, to be honest. I could do it, and I was okay at it. But when it came to working, I thought, okay, well, when I get out into the business world, into the IT world, it'll be different than classes. It'll be work, it'll be fun. I'll find my passion there. But that kind of never really happened, and it was actually the oil company I was working for that was kind of the biggest issue for me because I kind of consider myself an environmentalist, and here I am working for an oil company, and I was just kind of conflicted by that. And I think after about a year and a half of doing that, I just felt like I needed something more. Like I needed something that I could be passionate about, something that I could really sink my teeth into, and I just knew I wouldn't be happy in the software industry. So I started my journey trying to figure that out. And for me, it was traveling, which really brought everything to light for me. I did a year solo in Germany, in Berlin, actually, in my mid 20s, and oddly enough, there was a lot of people my age from different countries who came to Berlin with the same kind of idea in mind that they would kind of rediscover themselves and figure out what they wanted to do. So I really think this is a common thing for for people to do at different parts throughout their life. And it was there that I kind of I had to work at this software company to make money so I could stay there. But it was here where I started to kind of cultivate my interest in astronomy originally, um, and then eventually astrobiology.
Yeah, it's interesting what you're saying about Berlin. Because I've met actually a lot of Germans. I lived in Montreal for 3 years, and Montreal is pretty, there's a lot of people from Berlin because it's the kind of same vibe, the kind of
Hmm.
chaotic,
Yeah, yeah,
artistic,
totally.
cultural vibe.
I could totally see
Uh,
that. Yeah.
yeah, exactly. And so I can imagine that Berlin definitely you must have felt more free there in a way.
Yeah. Also, free and out of my element, and somewhat scared even. It was really the first time I had been on my own, and I was never really tested in that same way before. I didn't speak German when I went there, but I worked hard as soon as I got there to take classes and try and learn, on a weekly basis. And I just wanted to, yeah, I just wanted to figure things out on my own for the first time. And it's kind of crazy the kind of clarity you can get from just being out of your comfort zone, out of your kind of day-to-day life. For me back in Calgary, where I was from.
How
um,
old were you, Ben?
I was 24 when I moved to Berlin. Yeah, lived there.
Okay. Still pretty young though. I mean, still pretty young. It's good that you had that kind of, um, the ability to kind of reason
Yeah.
that it wasn't for you at that age, because I think, for a lot of people, especially in the software industry, because it is such a very popular field, and, our parents these days, they feel like that's the best future prospect for most people is to go into software.
Yeah.
So for you to kind of say, it's not for me, it's pretty gutsy. I gotta admit,
I
it's pretty
know.
gutsy.
I know. I really. The funny thing is I've been. It's been nearly a year, or sorry, 10 years since I was working at that software engineering job, and I've never made as much money as I made at that first software engineering job. So I gave up a lot financially as well.
Right.
Yeah.
So that's also interesting, right? Because we do give up a lot financially when we transition into new careers, but do you feel more fulfilled now that you're in science?
Yeah, for sure. My day to day life is so much better. Um, I get to think about the origins of life every day, and research this, and I get to teach as well, and it's so much fun, and I don't get paid too terribly. Like it's not as much as the software industry, but I'm in my last year of my PhD, so the process of grad school, it's kind of like you're paying your dues, and then afterwards, once you start doing science full time, then you start to get paid a little bit more decently. So I also, knowing that it's not bad at all.
Yeah, and you're still fairly young in the sense that you can actually enjoy, this new field. Like you're still going to have a good 30, 40 years in this field potentially. So that's kind of a
Totally,
good
yeah.
thing. Yeah,
Yeah.
totally.
I
Um
guess I'm really lucky actually. Now that I think, it's funny you really bring that out. But I'm the oldest grad student. I've been the oldest grad student in my program for almost, actually, for pretty much the entirety that I've been in grad school, because there's so many people who go, from a young age right into their undergraduate, and then right into graduate school, and then right into doing their PhD, and that process for them kind of finishes at 27. So it's funny. I'm not a whole lot older, but I'm in my mid 30s now, so it's. But you're making me feel really good about this, that I have so
I'm
much time. So thank you.
I'm in my mid 40s. You're just a kid to me, so,
Awesome. Uh,
And I just want to clarify for our listeners that you are doing your PhD at McMaster University out of Hamilton, Ontario, Canada, right?
yeah, that's right. Yeah.
How do you like McMaster? How do you like being in Southern Ontario?
McMaster is really great. Yeah, it's a really good department. a lot of really good profs, and the grad students are really we're a really good community, and I'm not sure if that's necessarily the case in every physics and astronomy department, across the globe, but we are really close, and we're a really good community. And Hamilton's a nice city. I'm really into the craft beer scene, and Ontario has an excellent craft beer scene. Tons of microbreweries around, um, and it's just, yeah, it's a nice place. There's a really great provincial park, Algonquin National Park, not too far away, where you can go hiking and camping. So I'm a big fan of this area.
Okay. Yeah, I'm originally from Northern Ontario. So, I think Hamilton is a little bit like Sudbury, but not. I think because it has the advantages of being so close to Toronto as well. So I guess if you
Yeah,
need the big city feel, you can just go to Toronto.
yeah, yeah.
Um, so let's get into the science because I'm sure that that's why everybody's going to be listening to this episode is to talk about the science and to listen, essentially learn a lot about it. Um, so you were recommended to me by an aquatic ecologist out of Nevada, Marianne Denton, and she said to me immediately, she said, "Oh yeah, he's studying the origins of life." And I didn't even ask her more information. I didn't even research you. Immediately contacted you when I heard that because I was like, "The origins of life? That's like the biggest question there is."
Oh, I know.
Really?
It so is. It's when I'm thinking about when I'm thinking about the biggest kind of questions that interest me the most. It's really, how do we get here, and are we alone? And it's like those two questions. It's really just, there's so much involved in them, and there's so much we don't know. It's kind of a big mystery still.
Okay, so how did we get here and are we alone? Do you have any answers to those questions?
I certainly have some answers. I mean, the field has existed for about a century, and people have made a lot of contributions and a lot of progress in trying to, solve parts of this story. So there's things that we know, but there's still things that we don't know, and I mean that's the case for any field, I suppose. But I feel like in this case, in this field in particular, we're fairly close to understanding how life emerged on Earth. There's really it really boils down to two kind of competing hypotheses right now, and researchers who focus on one or the other are working very hard to kind of fill the knowledge gaps in their that have to do with their hypothesis.
Okay, so tell me one. So for example, where did we come from? Do we have are you able to cuz I it's hard for me to formulate a question because the thing is I looked through your website real quick and of course there's like a link to your publications and I don't understand any of it because it's not in plain English.
Yeah,
So
sorry.
I guess no, I mean that's not your fault. You're an academic. I mean that's what you do. But so I guess my question is, do we know how life came? And you're saying there's two theories. Can you maybe answer the question
Yeah,
in plain
yeah,
English? And maybe tell me about those two theories?
yeah, for sure. So I guess as a little background, when talking about like we kind of have to define life, in order to answer this question, because life as we know it, uh, in every organism on Earth today, is very complicated. It involves DNA as your kind of information, your blueprint to make up you. Involves proteins, and those are the things that kind of carry out all the functions in the body and in every organism. And it involves RNA, which is kind of this. It's kind of like DNA. It's also an information molecule, but it has the purpose in life today of copying down the blueprint from DNA and sending it over to the ribosome, and then the ribosome translates this into protein so that you can have all these functions occurring in the body. So that's kind of the background of life as we know it. But we don't think that system, DNA, RNA, and proteins, and this complicated genetic code just kind of happened out of the blue. Like it's too complicated. And in Darwinian evolution, we kind of think about intermediate stages where you can have some sort of intermediate system, which is good, but not as good as the end product. So we think that first life wasn't DNA, RNA, and proteins, but we think it was just RNA. So it just simplified down to this one molecule, which is an information molecule. So it can be a blueprint, but it can also fold on itself and be like a protein. It can have behaviors that are like proteins. So it's kind of this intermediate in evolution where it's not quite as good as the system we have now, but it's a lot more easy to figure out how to go from simple organics that could be delivered to the early Earth by, say, meteorites or produced maybe in the atmosphere, all the way to RNA. That kind of process is a lot more easy to try and figure out chemically than getting to life as we know it, which is just so much more complex. So that's the background. So we're trying to get to RNA. When we're talking about the origin of life, we're actually talking about the origin of RNA, which can reproduce, which can replicate itself by, if you can imagine, just an information molecule with these four different bases. It's A, G, C, and U, but you could think of it as just like one, two, three, and four. These are four numbers, and you can put them in a sequence, and that's a unique piece of information that can be copied. So this RNA can copy itself, and the two hypotheses for figuring out how to get to RNA, how to get to first life on Earth, are either in a warm little pond, and this is something that actually Darwin came up with back in the 1800s, and crazy that it's still something that's very relevant and very likely today. And then the other is hydrothermal vents at the ocean floor, two very very contrasting environments, one on the surface within fresh water and one at the ocean floor in salt water. And these two hypotheses have kind of very different ways of going about this problem.
So, okay, take us back then. So, the Earth, after, I guess, is it the Big Bang?
For the well, so that's going way back. That's going really far back,
Yeah. Like,
back
at
to
what point do we think there was life?
uh, so 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 the Big Bang occurred at the emergence of the universe, which is 13.8 billion years ago. But for origins of life, you know, because we only know of life on Earth, and we know the Earth formed about 4.5 billion years ago. We kind of start the story there at the origin of the Earth, which where the Earth kind of formed out of all these boulders and asteroids and rocks, kind of in this disk of dust and gas around the early sun, and then it kind of built itself up out of all these rocky building blocks until it formed this huge molten sphere. And at that point it was not a habitable planet yet, but it was cooling, and it cooled slowly, and eventually it got to below the melting point of rock, and all the rock turned into nice hard rock, and you had a nice hard surface, and then it cooled more and got to below the boiling point of water. So all the water vapor in the atmosphere rained down and formed the first oceans, and then you had tectonics starting to occur, and then continents started to emerge out of the ocean, and on those continents you could have these little ponds where fresh water would kind of filter through, and you could have these ponds wetting and drying, and this is kind of the really favorable environment for creating RNAs in these freshwater ponds that kind of emerged on these continents that emerged out of the ocean. I'm leaving out a little bit of that story actually, because there is this huge moon forming impact that occurs at one point too.
No, but you know what? My mind has just been blown because I actually get it now.
Nice, yes.
Like, first of all, I get RNA now because, I mean, I was already pretty familiar with DNA, but I wasn't
Mhm,
really familiar with RNA. The way you explained it really was quite succinct for somebody who's not a scientist. So I appreciate that.
mhm.
But so now I guess my next question is, so billions and billions of years ago, this happens, tectonics happen. How do scientists, is it because do we study the world the way it is today and we estimate that that's how it was millions and billions of years ago? Is that how you start to piece the picture of life?
there's different clues from different kind of facets of different areas of science, actually. So to go back to the formation of the Earth, for example, we look through telescopes, say the Hubble telescope, for instance, or the ALMA telescope in Chile, at different stars that are just forming. And we take pictures and we see around them. There's always these disks of dust and gas around them. So we look at that and we say, okay, well, here's evidence of a forming solar system. So this makes sense as to how our solar system formed. We out of this same disk of dust and gas. So we can use the physics knowledge that we have, stuff like orbital mechanics, which really Isaac Newton came up with, and we can kind of run a simulation on our computers to make these disks form into planets and try and match them to what we see observationally. So that's kind of an example of how we know that that kind of part of the story pieced itself together. But there's kind of a more difficult part of the story, which is getting from the forming Earth to kind of a habitable planet, because we don't have an example of that. We can't look through a telescope at like a forming planet. Although we do actually have a couple pictures of some forming planets, but they're it's not what you think. It's not like a high definition image where you get to see a molten magma ocean. It's just a little blotch, and doesn't have a whole lot of information. So for that, we kind of have to look at the rock record. Um, we have outcrops coming out of places like Australia and Greenland, which have the oldest rocks on Earth, and they're about 3.9 billion years old. And so we know kind of before that everything was really kind of cycling through through subduction through the tectonic plates down into the mantle, and there's no rocks from before then because the cycling was too efficient. Um, so that's kind of just a whole bunch of stuff I just threw at you, but yeah, the basic kind of moral is there's kind of different facets. Different, we could either look through our telescopes for information of how things may have occurred, or we could look at the rock record, but that's also limited.
Yeah, because one of my first interviews was with Dr. Melina, who is a paleolimnologist. So she studies
Mm,
the history of past lakes through diatom fossils, which I found absolutely fascinating.
mhm.
So I imagine that even for this, you would have sort of a consortium of different science specialties, even archaeologists, perhaps.
Yeah, for sure. Astrobiology
Hmm.
has probably the most kinds of scientists. When we all gather for meetings, there's biologists, chemists, physicists, astronomers. There's geologists. There's microbiologists. There's all sorts of and then there's engineers, because there's all these space missions which are trying to search for life, and they're building these rovers, and and then there's even mathematicians who are looking at I don't know, the numbers, and I don't know how that life can emerge through that kind of process in a more non-intuitive way.
Okay. So, are there right now any examples in space that are kind of the closest that we think, of what the Earth was like millions of years ago?
Yes, Titan, actually, so Saturn's moon. Kind of sounds weird to say because it's a moon, but oddly, it actually has an atmosphere that is similar in pressure to the Earth today. It's got about 1.5 times the Earth's atmospheric pressure at its surface. And what makes it similar to the early Earth is not the temperature, because it's actually very cold there. It's so cold that methane exists in liquid form in lakes on the surface, but that the gases in the atmosphere would have been similar to what would have been present on the early Earth, which is mostly hydrogen and methane, rather than today, which is mostly oxygen and nitrogen.
Okay, now I have a new question then. You just kind of like implanted that in me. How does an atmosphere form?
Yeah,
Do you
so
know that?
there's yes, I
Okay,
do,
cool.
and this is getting more into what I'm researching right now, actually. Um, So I do atmospheric simulations of Titan. We've done some Titan ones, and now we're doing early Earth simulations as well. But essentially, you have your primary atmosphere, which is what you gather from that disk of dust and gas as the planet's forming. But that's not actually the atmosphere that matters as much because at that point in time the Earth is molten, it's so hot, and you're losing all these gases too quickly. It's actually the outgassing from volcanoes and also the outgassing that occurs when you have a large impact on the surface. For example, if you have an impactor that's made of iron, that iron will interact with water in the atmosphere and it will produce hydrogen gas. A lot of it, and there's a lot of impactors on the early Earth. It was crazy. It was just meteorites were bombarding left, right, and center. Bombardment rates were 100 million to 100 billion times more than they are today. So it's really it's really hard to imagine what that would be like if you were standing on the surface of the early Earth. You would probably look off on the horizon and see all these streams of impacts all around you if it wasn't occurring right over top of you. Yeah, that's pretty much how you get the original atmosphere, and then all the chemistry takes place in the atmosphere from those major molecules that you start with, like hydrogen and methane.
Wow. So essentially, it just dawned on me when you were talking is that the research that you're doing, you're studying the past, but is there potential for perhaps using this research to create an atmosphere, like, for example, on Mars or wherever else, in the future?
Yeah, totally. It's perhaps more dangerous game. But if you were to, for instance, nuke, the North Pole on Mars, you would release all this CO2, all this frozen CO2 and frozen water into the atmosphere, which are two of the most potent greenhouse gases, and that would essentially slowly heat up the atmosphere. But the problem with Mars is that it's so light. It's not as heavy as the Earth. It can't hold on to atmospheric gases as easily as the Earth. So the solar wind kind of strips them away. So you would have to keep doing that. You'd have to periodically nuke the poles if you wanted to make Mars habitable.
Oh my God. So is Elon Musk investing all this money for nothing then?
Well, I think it's really cool what he's doing, and I think he even knows that people are going to have to live, in their habitats that they make for themselves for a long time. But it's humans are we're pretty creative. If there's a solution to maintain habitability on a planet long term, then it might take us a million years, but but I think we can get there.
Yeah, all of this is just, I mean, you gaze up at the sky and all you see are just a few stars, especially if you're in the city, you're not going to see much. But then you go out into the country, like when I go back home in northern Ontario and I see the Milky Way and I see, all these beautiful stars and sometimes you see a shooting star.
Mhm.
What's it like for you to gaze up at the sky now that you know all these things?
That's an interesting question because I do love stargaze, and I had a telescope at one point and would spend a lot of time on it. And I think actually what I think about mostly when I look up at the stars is I'm looking for something, like I'm looking for Cassiopeia, or I'm looking for the Big Dipper so that I could guide my eye to the North Star. I think I do it more for like kind of the kind of constellations and kind of amateur astronomer type things. Um, it's when I'm sitting down at my work desk, kind of staring at my laptop, or just kind of off in the distance, that I'm really thinking about the origin of life. Maybe less so when I'm actually out there in the environment. I don't know why that is.
Oh, that's interesting. That's yeah, of course. I guess it would make sense because you're just not in front of it in that moment.
Yeah, yeah.
Huh. Okay. You mentioned earlier the word exoplanet. I've heard it before, but I'm not really sure what it means. Can you explain what an exoplanet is?
Totally, yeah. So we, we have a solar system that has 8 planets, um, and some dwarf planets like Pluto. And we have our star, and we all orbit around this star. All the planets orbit around the star, but we're not unique in the universe. Every star, pretty much every star out there, has at least 1 or 2 planets orbiting it. So we call all of these planets that are in different star systems exoplanets. And it's been predicted that um, there are maybe, on average, we'll say 2 planets per star, but that's probably an underestimate. And there's about 400 billion stars in our galaxy, in the Milky Way galaxy, and then there are about 1 trillion galaxies in the universe. So if you think about how many planets that is, it's really hard to imagine that we would ever be alone.
Well, that was the next thing I was gonna bring up, which is that I'm 44 well, I'm gonna be 44 years old. I think we're gonna find life elsewhere before I die. How do you feel about that?
I agree, and I think I actually th- I actually think it's most likely to happen close to home. So I think Mars is probably the best shot we have uh, to finding life in the next, say, in the next decade or so.
Why do you think
Um,
it's Mars?
well, I guess the difficulty with so if I'm contrasting this with finding life on an exoplanet, the difficulty of finding life on an exoplanet is that you have to use biosignature gases, and that's looking at the atmospheric composition. And we have telescopes that are capable of this, and there's a big one going up next year, the James Webb Space Telescope, which will do a really good job at getting the exact atmospheric composition of these exoplanets. And if we see some signatures, maybe a lot of oxygen, like on Earth, where most of the oxygen is made by, well, actually by diatoms. So linking back to your to your other interview, um, or a lot of methane, and there's a lot of methane produced by life on Earth, or maybe phosphine, which is this new exciting exoplanet gas that was found on Venus, which may suggest that there's actually life in the clouds on Venus. So it's you have to rely on these gases, and it's really hard to be conclusive about that. There's a lot of skepticism in science. That's kind of the name of the game. We write these papers, we do the science, and then we go to peer review, and our peers say, okay, maybe this is the case, but more data is needed, more observations are needed. You need to really make sure that this is what you think it is. So I think it's more likely on Mars, where you can actually go there with either a rover or maybe even an astronaut, take a sample, look under the microscope or put it through a mass spectrometry or some instrument which can give you the composition, to be more conclusive when it's right there in front of you.
Yeah, and I think we can pretty much confirm, at least by now, that there are no like aliens the way that we see them in science fiction on Mars. I think if we find life on Mars, it would just be probably like a molecule or something, right?
Yeah, 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 yeah. Totally. It's the little green men is not the way that it's likely life likely exists in the universe, but rather it's, if life does exist, and it's pervasive throughout the galaxy, say, it's probably mostly bacteria, both mostly microorganisms.
So, you're a member of the scientific community that's studying this. What would happen if we did find, let's say, a new bacteria on Mars? Like, what's the first thing that would happen in the scientific community?
Oh, that would be amazing. That would be the best day ever. But it would also be met with great scrutiny. I mean, hopefully before, um, yeah, probably before it gets announced, it would go through the peer review process. So it would already have gone through one layer of scientific scrutiny to make sure, yes, we agree this is a detection of life. But once that occurs, it's going to get there in the media, and people are going to go crazy, because that's, it'll, for the first time, we will have evidence that we aren't alone, that life isn't unique to Earth, and that is such a big, huge philosophical, you know, conundrum. It'll change our perspective. It'll change our perspective of what it means to be living. If life could exist on Mars, then it's probably pervasive throughout the galaxy because Mars isn't even that habitable of a place. So that would be
Right.
crazy.
Yeah, I think that I mean, there's like you said, there's the impact in the science community, then there's the impact in the global media, religious communities,
Hmm.
and then we're looking at medical communities as well. I mean, what does it mean to introduce a foreign bacteria potentially? I mean, I'm sure it would be completely
Yes.
safeguarded. I would
Yeah.
hope, you know. But what
Yeah.
is what's the potential? And then we have private space enterprises that are going to be taking off and doing their thing. So I think there's a lot of questions and a lot of ethics to observe in regards to life on other planets.
Totally. Yeah. There's kind of a facet of astrobiology, called planetary protection, and this is where they really think through these questions, and this is actually one of the reasons why there's certain places on Mars that are kind of off limits for even rovers, because rovers are not sterilized to, you know, to infinity. They're it's really hard to sterilize something to the point where there's actually zero bacteria on it. It's You may get down to, very small amounts, but all the rovers we've sent to Mars have some level of life on them, and it's just really, they can't really survive in those conditions. So it's not really a big worry. But there's certain areas like the South Pole of Mars where there's subsurface lakes that you're just not allowed to go to because the fear of contaminating that area with human life, or destroying the habitat of life that already exists there, that are, too big of questions to just let someone go there.
Wow, I
Yeah.
I hadn't even thought about that. That's really fascinating. Is it possible that so I do live streaming on Twitch with my microscope,
Hmm.
and I show the world, tardigrades. Tardigrades are such a big popular thing these days. So I show them live tardigrades, and one of the questions that comes up a lot is it possible that tardigrades are from a different place, like they came to Earth on comets or
Mm.
something? And I'm sure you've heard questions like that before. So is it possible that we've already had life introduced to Earth through comets or meteorites?
Yes, the kind of panspermia hypothesis. I think I think there are a couple of ways of thinking about this. There's kind of like geopanspermia, which is, let's are we transferring life from Earth to Mars, and from, Earth to Venus, and Venus to Earth, and Mars to Earth. And I think the answer for that is absolutely we are, because we have meteorites, Martian meteorites on the surface of the Earth. So we know that if there's a big impact on Mars, that it can send projectiles in our direction, and vice versa. I'm certain that there are, Earth meteorites on Mars, and life is streaming throughout soil and rocks, and is very possible that tardigrades themselves, which are everywhere in water, in different water sources, could also be within these rocks and be sent, say, to Mars, or vice versa. But it's really hard to prove that's, how life emerged, say, on the Earth. And all that's kind of saying is that, well, now you have to figure out how life emerged on Mars, or if you find life on Mars, we still have to figure out how life emerged on Earth, because it maybe was delivered there. But then there's the
Yeah,
idea of getting it from a different solar system, from like an exoplanet, and I think that's much more unlikely.
because if they were to find a tardigrade on Mars, they would have to first prove that they didn't introduce it there, right?
Hmm. Hmm.
Okay,
That would
okay, that makes
be,
sense.
unfortunately, like, that would be somewhat disappointing, because, yeah, because that does suggest that, A, maybe you just brought it there. Like, maybe even just brought it there that day. Or B, maybe it was, actually, if it was a species of tardigrade that is on Earth today, that that would probably be the likely conclusion of that work. But
Okay.
maybe if it was a species of tardigrade that was never discovered on Earth, and it can be shown that it evolved on Mars, say a very early species of tardigrade, was transported to Mars, say 100 million years ago, and evolved in the cold, salty, arid conditions of Mars into this new species of tardigrade. That would be exciting. Um, yeah, that would be much more exciting.
Yeah, I'd be I'd be super stoked about that for sure.
Yeah,
I want to put science aside for a minute here, kind of,
sure.
because I really enjoy your website.
Oh, thank
I just
you.
I just wanted to mention that because
I appreciate
what I
it.
like is when scientists, and I know there's a big push right now, and I know a lot of scientists aren't happy about it, but there's a big push for science communication right now.
Mhm.
There's a lot of disinformation out there, so it makes sense. I understand. But I think sometimes it's nicer when it's the scientists themselves that come up with the idea. Now, in your case, did you come up with the idea of creating your own website?
No, actually,
No.
I mean, I went to a career kind of workshop at a conference, and I was a master's student, and basically, I was like, "Is it too early for me to have a professional website as a scientist?" And she was like, "No, absolutely, you should have a website. Build it tomorrow." And I was like, "Oh, okay." So I got to work, and I kind of realized that in science we we kind of have to ask for funding throughout our entire careers. So you really need to be a good science communicator in order to get that funding. You have to convince the public, you have to convince agencies that your science is worth funding. So
Okay, and now
yeah,
communication is a part of that.
yeah, it's a huge part of that. Yeah, not
Okay.
only yeah, and I mean that's one important reason, but also getting science out to the public is also key. You don't want to keep all your science to yourself. That's no fun. You want to share it to with everyone else.
Yeah, especially in the age of flat earthers.
Yeah, who still exists somehow. That's yeah, insane.
It is interesting to me. I find it more than anything. I find it fascinating. To be honest with you, I pose no judgment on anybody who believes in that, but I do find it fascinating. I find I find it fascinating that science hasn't necessarily figured out a way yet to actually communicate itself,
Hmm.
and it's just beginning, which is fun, which is good, and it's fun that you have a website and that you have a blog, and that not only do you talk about science on your website, you also talk about your hobbies and interests, which again it makes you look less like you're part of like an ivory tower kind of system, which is
Yeah,
important.
yeah, yeah,
It's
totally.
it's very important.
Yeah,
Uh,
I'm a
yeah, go ahead.
huge believer in not just doing science. Like I very much cherish my weekends and my evenings for my hobbies and for doing much other things. And I do my work during the week, and I love this. I love time off, and I actually think it's necessary just for general happiness to kind of not only be thinking about one thing all the time, but just to give your brain a break.
Yeah, and you're dealing with really big questions and this kind of research, I mean, it is very much an obsession for a lot of people, whether you're an artist or a scientist. You're constantly obsessing about problems and solutions and kind of like being a software engineer, I guess, but in this case you're really, having fun doing it.
Hmm.
So, what do you do with your free time? What's your gig? What's your hobby?
I've got a few. I think the hobby that I'm doing a lot of right now, or I guess the two major hobbies I'm doing a lot of right now is brewing beer and rock climbing. Um,
Ah.
yeah, so I like the rock climbing to kind of get some exercise in a fun way, and I like beer brewing for kind of the creative aspect because it gives me an opportunity to build a recipe and kind of explore different kinds of yeasts and different kinds of hops and even different grains and just see if I can make something that is unique and delicious.
Do you
Yeah.
know Dr. Brian Height out of, Western?
Uh, I does not ring a bell. I should know.
Okay.
I should know because Western's so close to me.
Well, I only bring him up because he's huge into that scene and, like most, Ontarians, I guess.
Yeah.
But he was on the podcast. He's an immunologist.
Oh,
So,
yeah.
maybe I'll put you guys in touch, but he's gonna send me some yeast to look at under the microscope.
Oh,
So,
cool.
yeah, that's gonna
Yeah,
be
yeah.
fun. It's gonna be fun.
Oh,
But
I
I don't
wanna do
I
that. I wanna tune into that Twitch actually, 'cause I've never looked at yeast under a microscope. I don't know I don't own a microscope, but I now I kinda wanna buy one.
Oh, you totally should, totally. We'll talk after this, but, so beer, I mean, see, I don't drink beer, so it's very hard for me to even ask questions about it because I don't know a lot about beer,
Mhm,
but I do know that it really does become an obsession for a lot of people, and like you
mhm.
said, in Ontario, it's a big thing right now is craft beer. So, how did you get into craft beer? Why do you do it, and what's your favorite kind of beer?
Uh, okay, I how did I get into it? I think I had a friend actually who I heard brewed beer, and I was just so fascinated that you could do that. It just seemed so I don't know so professional. Like I knew breweries did it, but I couldn't imagine people could do it in their own homes. And he kind of helped me with buying the necessary equipment, with setting up me up with my first batch, and after doing that, I was kind of just hooked after that. It was so much fun to brew that beer and actually have this end product that was tasty and that was, just something I couldn't fathom making myself that involved fermentation, in this big vessel over a couple weeks. And it was just, and then carbonation after that. It was just such a fascinating new experience for me, and the process of learning, because I love to learn. I mean, I think most people who do their PhD are big fans of learning. So just given gotten the opportunity to learn how to do it, that really just hooked me. And my favorite beer uh, right now actually uh, is probably a Kolsch, which is like a it's like a lager that they brew in Cologne in Germany, kind of exclusively. But Ontario makes a lot of kind of clones of this type of beer.
Okay, so that makes a lot of sense. So I guess there's links between your beer brewing and your time in Germany.
That's yeah, that's I think probably one of the reasons why I was so attracted to choosing Berlin as kind of my travel destination was because I love drinking beer, and I just knew you know stereotypically that Germans love beer. So I was like, okay, I mean, seems like a pretty good place to me. So that was my one of my major reasons for going there. And when I went there, yeah, I tried a lot of their beer, and it's fantastic over there.
It's interesting because I don't, a lot of people who listen to this podcast, they say to me, I really like that you get to know the scientists, because because you're not just presenting the hard facts and we're presenting actual people. At the end of the day, you're still a human being with varied interests. One of which is also hot sauces.
Oh yeah,
What's
yeah,
that all about?
yeah. I love spicy food. All sorts of spicy food, and it's so enjoyable. Like just to I love the like bite from capsaicin. It's so I don't know why, but it's just so enjoyable to eat a really spicy meal for me. And a lot of people think I'm crazy. I put for breakfast, most mornings, I'll have a bagel and I'll put peanut butter on it, and then I'll have sriracha, and I'll just pour I'll pour that on top of my breakfast bagel, and it's so good, and I love that bite. I love all sorts of hot sauces, all sorts of spicy peppers. It's just kind of like yeah, it's just something I really enjoy.
Yeah, I think you're weird.
You're not
I,
alone in
I,
thinking
I'm
that.
sure, I'm sure. Um, but I'm curious now because did you grow up with parents who, also enjoyed hot sauce? Because I have a bit of a theory, which is that if you grew up with a very bland kind of Canadian diet, meat and potatoes, you're probably not gonna like hot sauce. So I'm curious, what was your food like when you were growing up?
Oh, that is interesting. I would say that that actually, my mother cooked mostly, fairly basic Canadian meals, which did not have any spice in them. However, my parents are separated, and my dad ended up marrying a Filipino woman who really brought spice into that home. So maybe, yeah, maybe a little bit later on, probably in my mid-teens, I started actually incorporating spice into my meals. But at an early age, not so much.
It's science, I'm
Yeah.
telling you. It's something to do with
Theory
early.
proved.
Yeah. There's something to do with early introduction to spice because everybody I've ever met who enjoys spicy foods were introduced to it sometime either in their childhood or as a teenager. Usually starts with like a basic, hot sauce. Um,
Mhm.
and I've just started introducing it in my 30s. So,
Ooh.
and it's still taking me a really long time. Like I think the only brand I really enjoy now is I think it's pronounced Cholula.
Oh, yeah, yeah.
The very basic,
Yeah, yeah.
but it's good for people who don't have that kind of tendency like you do, you
Yeah,
know?
it's a nice, just, mild kind of hot sauce, kind of, has a good flavor to it too. For I like it on Indian dishes.
Mm.
Mhm.
Yeah, yeah, it tastes good, so that's why I still consume it, but I think it's a very unique it's a unique perspective to put hot sauce on your breakfast foods.
Yeah, yeah. I mean, I always tell people, like, don't knock it until you try it, but that only really is valid for people who like really like hot sauce.
True, true.
Yeah.
Have you thought about, because you create beer, is it possible to create hot sauce at home?
Yeah, I've definitely made hot sauce before. I've only made one type, so it's vinegar based sauce. Um, but I have friends who have gardens. I don't have a garden anymore, sadly. Otherwise, I would definitely grow my own peppers. But I have friends who have gardens and grow peppers, and I make sure that they at harvesting season kind of give me a bunch so that I can make a bunch of hot sauce and share it with everyone. And the one I made this year was the peppers themselves. I have no idea what they were, and the guy didn't know either because he just kind of picked up a bunch of seeds and didn't hold on to the names. But I added ginger, so it was a ginger based hot sauce, and turned out really well. Yeah, people enjoyed it.
Okay. Did you name it after something in space?
Oh, what did I call it? Ginger. No, I didn't name it off something in space. I don't remember the name though.
Okay.
No.
So what is next after you're done your PhD? What is the ultimate kind of job or the ultimate thing that you want to be doing?
So right now I'm in the last year of my PhD, so I'm applying for jobs right now. Actually, the kind of season of applying for postdocs uh, is right now, and kind of finishes when the new year kind of comes in. Offers start to be put out in February. So I'm most interested right now in continuing this science, and I'm really interested into moving into kind of experimental research, so that we can kind of test out our hypotheses in the lab. Kind of fill a reaction chamber with these atmospheric gases and try and simulate the process from an atmosphere all the way to RNA. So I just kind of want to keep doing the science. It's what I came here to do. It's what I spent all this time, educating myself in this field and doing this research, and I just want to keep doing it. And I guess the natural progression from there is to become a professor and to kind of start your own research group, and continue doing that research through that way. So I'll see if I can do that.
That's interesting. Have you considered maybe working for a space agency or like a SpaceX kind of thing?
Yeah, I definitely have. I definitely love I definitely love the space sector too, and I have thought to myself, if I'll probably try academia first and see see if I get a lot of momentum there. But if not, like I would be very happy working for a space agency as well. Um, SpaceX, I know, I don't think that they hire internationally because I think there's something about the fact that they're working with rockets that's kind of like national security ish.
Okay.
Um, but maybe another, maybe another space company. I would love to work for SpaceX because they're the ones most likely to go to Mars first. But I'm not sure if I can.
Yeah, I bet. I mean, there's always potential for other competitors, but I think, like you said, the first ones are probably going to be SpaceX, and I don't think it's going to be a governmental organization. I think it's going to be a private industry endeavor.
Yeah, I agree. Definitely.
Hmm. Well, yeah, it's been fun, Ben. I feel more excited than I did yesterday about space,
I'm
and
glad.
definitely, I would love to talk to you again, just because I know there's a lot of stuff that's going to be happening over the next year or so. I think there's like you said, the new telescope is going out,
Hmm.
and
Yeah.
there's a few like Mars. There's a Mars mission, isn't there?
Yeah. There's actually two Mars missions uh, kind of happening simultaneously. One from the European Space Agency and one from NASA. So yeah, a lot of Mars stuff going on right now.
Okay. So, last question then is what do you recommend to someone who wants to learn more about astrobiology and the origins of life? Do you have like a favorite book or a favorite documentary or something?
Ooh. Uh, yeah, that's a great question. There are a lot of different resources out there. Looking at the NASA Astrobiology Center is a really good resource. There's a lot of good YouTube videos out there as well on the origins of life, and I know there's certain YouTubers like David Kipping, for instance, who has a cool worlds channel, and he's a really great science communicator. So that's a good resource. There's a lot of people on Twitter who tweet a lot about astrobiology. People like Planet Doctor Sarah Hurst, and um, there's some other prominent astrobiologists. I don't know, my mind's kind of blanking right now, but
That's okay.
but yeah, there's definitely on YouTube. There's definitely a lot of resources out there if you type in astrobiology and are interested.
Okay, yeah. As always, there's always stuff online, but it's always good to ask the experts who they recommend as legit sources of information.
Totally.
Well, listen, thank you very much. I wish you the best of luck in wrapping up this PhD and into your
Thank you.
postdoc.
I appreciate it, Julie. Thanks so much.
Thank you.